Functions of several variables. A function of two variables z equaling fxy maps each ordered pair xy in a subset D of the real number plane R2 to a unique real number z. The set D is called the domain of the function. The range of f is the set of all real numbers z that has at least one ordered pair x, y, and d, such that fxy equals z as shown in the figure. Now here's that figure. Now looking at this figure here, we see that this blob here, this is coming out of the xy plane. And that's what it's saying here. It says my D is the real plane R2. So this is like my, let me draw it two-dimensionally so you can kind of see it. That could be my xy. And it's going to map to z. So that's the idea here. And that z is just a height. It's going to be the height of that function. So if we think about this three-dimensionally, and we put this on the xyz coordinate plane, I could say, hey, this xy point here is going to, once I plug it in the function, will be way up here. So that would kind of be the idea of what we're dealing with. And z is just this number line in a sense. So that's what we see here. So if that was it there, then that would be this point here. And this 0 would be down here somewhere. So that could be like 6 or 7. So that's the idea of it. So the z is just the height of how high that point is going from the xy plane. And that's how that works here. So yes, it's just going to be a single number on a number line. That's how we can think of the z's. So let's get started with this problem here. It says find the domain of g of xy, equaling the square root of 16 minus 4x squared minus y squared. Now here we're just looking for the domain. And that's what they said. Domain is in R2. And it's called the domain of the function. So we're looking at two-dimensional domain here. So it's not one-dimensional anymore, where I can say all real numbers or from x is from -2 to 2. I'm not going to say anything like that now because this is two-dimensional. So that means it's on the xy plane. This is the domain. Okay, so what we're going to do is we're going to look at what's underneath here. So when I look underneath the square root, I know a square root, I can't take the square root of a negative number and get a real value back. So whatever's under there has to be greater than 0. But it also can equal 0 because the square root of 0 is 0 because 0 times 0 is 0. So what that means for us then is all I have to consider here is the 16 minus 4x squared minus y squared has to be greater than or equal to 0. And I just write down what I actually said there mathematically. And from here, I can solve this inequality. In a way, I can. Not completely. I'm going to move the 4x squared and the y squared over so that they can both be positive. So I have 16 greater than or equal to 4x squared plus y squared. Now what I would do is I would divide by 16 because this is looking a lot like a ellipse. So that's what I'm looking for here. So that's what I'm going to divide by 16 so I can get a 1 here. So I know my ellipses in general form is an x squared variation plus a y squared variation equals 1. So I have to have a 1 there for that to work. So I'm going to divide by 16. So when I divide by 16 here, and I'm just going to write it out. That's going to give me a 1 greater than or equal to, and this is going to be an x squared over 4 plus y squared over 16. So there's my ellipse, and I could actually draw that ellipse out, and I will. I want you to see what this looks like. So remember with ellipses, they're really of the form, and I'm just going to write out the equation itself for this specific one here. So this is really x squared over 2 squared plus y squared, and this is just going to be the boundary here, over 4 squared, and that equals 1. So that's what I'm going to graph here, and then we're going to play around with that inequality to kind of see where everything's at. So this means this number underneath that's squared, that means my distance from the center. And because I don't have any shifts here with the x and the y, they're centered at 0, 0. So my x is going to be 2 away from the center. So let me label my axes here because now we're just two-dimensional. So there's my x, there's my y. And my x is going to be two away, so my point would be, I'm going to make it a little larger here. So my point for my x's is going to be two away from the center, positive and negative. And then my y's then is going to be 4. It's going to be here and down there. Okay, now we can just create this ellipse here. That's the nice thing about it. Once we understand what we're dealing with here, it makes it easy to graph. So there's the ellipse there. Now we're wondering, hey, what is that going to actually be? Is it going to be outside or is it going to be inside? What I generally do is if 0, 0 is not on the boundary, I plug that in. Now again, I'm not going to use this for that because that's just an equation for the boundary. And that's where that came in at. That was just to graph the boundary. Now we're looking at the inequality itself. So if I pick 0, 0 here, and I plug it in, my inequality here, I'm going to end up with 1 greater than or equal to 0. And that is a true statement. So what that tells me there is that tells me that the actual domain is going to be anything inside of this here. So that's what that tells me. So if I was to think about all the points that would work for this, it would actually be inside of this here for this function. So another way I can write this, now again, you don't have to do the graph unless specifically asked for that. This was just for a little understanding of our domain. So to write this in set builder notation, because that's what we would use here, this would be an xy, an element of R2, such that, and then I would just put this inequality in here. So 1 greater than or equal to x squared over 4 plus y squared over 16. So like I said, we didn't really need the graph here unless it was specified in the directions, and it wasn't for this one. I just had to find the domain. So this would have been sufficient for the answer, but I wanted you to see exactly what that entailed as far as what it looks like. And now think about this. It's being projected 3D. So if my z was 0, that's the picture I would get if I did a trace. So that's the video.